Okay, now that we have learned about the different types of methods to find LCM, in this slide we are going to solve a few of the questions related to LCM using those methods. So the first question says find LCM of 3 and 4 using listing method. Second question says find the LCM of 6 and 8 using prime factorization. And the third question says find the LCM of 5, 10 and 15 using division method. So we are going to solve this question one by one. I know the answer is already given, and if you do want to try it yourself, please pause the video and do so. Okay, let's solve the question one by one. First, finding the LCM of 3 and 4 using listing method. So in this method, all you have to do is list the multiples of each number. So the multiples of 3 are 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, and so on. And the multiples of 4 is 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and so on. So now that we have listed the first 5 multiples of both numbers, let's see if there is any common multiple among them. And you'll see 3 is not common in 4, 6 is also not common in 4, 9 is also not common in 4, but 12 is common in 4. Now, since it's the first common multiple, it is also the lowest common multiple. So 3 and 4, the LCM of 3 and 4 is 12. So that's how you use listing method to find the lowest common multiple. Now let's move on to the next question. We are asked to find the LCM of 6 and 8 using prime factorization. Now in this method, first we have to factorize both 6 and 8 into prime factors, and we know that in order to do that, we know that 6 is nothing but 2 times 3. So the factors, if you are to write in prime factors, it will be 2 times 3, and both 2 and 3 are prime. Now 8 is also 2 times 4, but 2 is prime but 4 is not prime, so we can further break down the 4 into primes, which is 2 times 2. So 8 is 2 times 2 times 2. Now that we have factorized both 6 and 8 in terms of prime factors, let's list them using a table. The first one will be 6, second one will be 8, and the last one will be LCM. So remember, in this method we are asked to list the prime factors of each number in a row. So the 6 prime factor would be 2 and 3, whereas the 8 prime factor would be 2. Since it's common, we write one above another. And next, we don't have any 3's as the factor of 8, so we leave it blank, then write another 2 and a 2. So notice only one of the factor is common in both the numbers, so we just count it as 1 and write it below. Then 3 will come down, and 2, 2. So the LCM of 6 and 8 would be 2 times 3 times 2 times 2. Now we know that 2 times 3 is 6, times 2 times 2 is 4, and 6 times 4 is 24. So the LCM of 6 and 8 is 24. So this is how you solve using prime factorization. It is not that difficult. Make sure you just practice some more questions and then you'll be comfortable with it. Okay, so the third question is asking us to find the LCM of 10, 5, and 15 using division method. Now in this method, all you have to do is make a line like this here and write down the numbers. Then first check if it's divisible by 2 for all the numbers here. And as you can clearly see, 5 is not divisible by 2 and 15 is also not divisible by 2. Now let's check if it's divisible by 3, and you'll see 5 is again not divisible by 3, and 10 is not divisible by 3, although 15 is divisible by 3. Let's move on to the next prime number, which is 5. Now you'll see that these numbers are all divisible by 5, so write 5 on the left column and divide all the numbers by 5. You will get 1, 2, and 3. Now at this point, you'll see that there is no number that divides all these numbers, so you just divide one of the number by itself. So I'll divide 2 by itself and leave 1 here, 1 and 3, and then now to make 3 1, you divide 3 by 1, keeping 1 here, 1 here, and 1. So this number on the left columns will be our LCM of 5, 10, 15 equal to, now just multiply these factors on the left column, which is 5 times 2 times 3. So we know that 5 times 2 is 10 times 3, which is 30. So that's how you find LCM using division method. Let me know in the comment section if you have any questions related to this method or the prime factorization method.